Hello students! In this video, we're going to be talking about the number systems, and then I'm going to share one of my favorite stories of a mathematician who was killed because of one of these systems. Let's get started. So what are number systems? A number system is a way we can categorize numbers. Just like how in biology we can categorize living things based on their kingdom, family, and species, we can do the same with numbers. We know that there's plenty of numbers. In fact, there's an infinite number of numbers, but they all fit within 5 nice categories. The first category of numbers are the natural numbers. Natural numbers include the numbers 1, 2, 3, 4, and so on. These numbers are called the natural numbers as they are the numbers that came most naturally to people when they first started counting. In fact, they were among the earliest used numbers in history. 0, as we know it, wasn't even used by people until the 7th century. Speaking of 0, if we were to start counting from 0, as in 0, 1, 2, 3, 4, we'd get the next system of numbers, the whole numbers. The whole numbers are all of the natural numbers and the number 0. Notice that as I'm writing these lists of numbers, I have this fancy curly bracket around the list. That's how we denote a set of numbers in math. This is important for us mathematicians to be able to categorize a list of numbers. The next list is the set of all integers. These are numbers we've already talked about and their negative counterparts. Integers are really important as they're used to make the next set of numbers, the rational numbers. Here's the definition for rational numbers. A rational number is a number that can be written as a fraction or a ratio between two integers m and n, where n is not equal to 0. Let's deconstruct this definition a little bit as there's a lot of mathematical jargon. First, I wanted to talk about where the word rational comes from. Well, if you notice, the word ratio is in the first half of the word rational. This is precisely where the word rational comes from. We also see that this ratio is really just a fraction between two numbers that have to be integers. The final bit of math jargon we see is that n cannot be 0. That is, because if it was 0, we'd be dividing by 0, and that's a no-go. And an example of a number that's not a rational number is pi over 2, because pi is not an integer. Neither is 3 over 0, because we'd be dividing by 0. When we have a 0 in the denominator, we say that this number is undefined, and we have a nice little symbol for it. 3 over 1, however, works just fine. But hold on, isn't 3 over 1 just equal to 3? Well, yes it is. In fact, any integer can be written as a fraction with 1 as a denominator, so in fact, all integers are rational. 3 over 2 is also rational, so is 5 over 2, and even negative 5 over 2. All of these numbers are rational. We also see that decimal numbers can be rational too. For example, the number 0.123 can be written as 123 over 1000. Which is definitely a fraction. We also see numbers like 0.333 repeating, written as fractions, like 1 over 3, which you may have seen before. Now, before we get all excited, I wanted to note that not all decimal numbers are rational. Some decimal numbers go on forever, like 0.33 repeating, but they don't repeat in the same way as a third does. These numbers can include numbers like pi and the square root of 2. They belong to our final number system, the irrational numbers. Irrational numbers are simply numbers that are not rational. That's a nice and simple definition. In the next video, we'll go over some strategies to how we can spot the difference between irrational numbers and rational numbers. Remember how I just said that irrational numbers were our last number system? Well, I lied a little bit. There's actually 2 more. Remember how in biology we could group living things into different categories? Well, living things themselves are really just one big category, and there are subgroups inside of it. Species belong to a genus, which belong to a family, and so on and so forth. Numbers do the same thing. Natural numbers belong to the whole numbers, which belong to integers, which belong to rationals. Rationals finally belong to the real numbers, and the missing space that aren't the rationals is simply the irrationals. This is the overall view of how all the numbers are grouped together. The final number system is a set of imaginary numbers. We won't be talking about them today or in high school at all, but if you're interested, I'll be providing some resources in the video description if you wanted to find out more. Before we go, I promised I would share a story of a famous mathematician who was killed because of some of these numbers, and that is of Hippasus, who discovered irrational numbers and was punished as a result. Hippasus was an ancient Greek mathematician who lived over 2,000 years ago. He is attributed as being the person who discovered that there were even such things as irrational numbers, as he showed that the square root of 2 could not be written as a fraction. Ancient Greeks loved rational numbers and thought that they were divine. So when a number appeared that broke this divinity, they believed this offended the gods. And so they punished Hippasus by drowning him at sea. Today, we know that they were wrong and Hippasus was right, and we know that there's an infinite number of irrational numbers. Because of him, we have this knowledge today, and we can be thankful for his sacrifice. On this final note, I'd like to thank you for watching the video, and I'll see you in the next one. Bye!